So in this question, it says we're going to use a table to figure out what the limit is as x approaches 0 of this function. Now, the purpose of a limit, which I think gets glossed over a lot of times, is we're trying to answer a question that would normally be unanswerable. So what we have here, right, for example, sine of 2x over x, if you actually just said, hey, what is the value at 0? What you would see is you would say sine of 2 times 0, which is, of course, 0 over 0. Sine of 0 is 0 over 0. This is an indeterminate value, okay? So this is not answerable. But what a limit allows us to do is instead of asking what is the value at 0, it's saying, well, maybe it's indeterminate right there. Maybe a value doesn't exist, but is it approaching a value? Is this function converging towards some sort of value near 0? Hey, there might be a hole there. It might not actually exist, but again, there is a potential value that it is approaching, and that's what a limit aims to answer. So now if we look at the graph of sine of 2x over x, you can see that from the graph, it's not as though there's nothing here. It is approaching a single value, right? From both sides, left and right. It seems to be approaching this value of 2. But then when we get right to that point, right when x is equal to 0, you notice it says undefined. So the limit is going to answer the question, not what is exactly at that point. That's undefined. But what it's answering is what is the value? What's the function value that we're approaching from the left and right-hand side? So when we calculate a limit, what we're doing is we're slowly getting closer and closer to 0. So you can see that these values from the negative side, from the left side, we're slowly approaching a little bit more closely to 0. And then we're doing the same thing from the right side, again, starting at 0.1, then getting closer and closer to 0. And we're just looking to see the trend. What are the values approaching? So here's our table, right? What I'm doing is I'm plugging in these values, getting closer and closer to 0.00008, basically 0, right? So we're going 0.1, 0.01, 0.001, etc. Now you can see the progression. Again, this is from the right-hand side. We're getting closer and closer to 2. This actually says 2, but that's because they rounded. It's still going to be like 1.9999999, not exactly 2, but it's clearly going towards 2. And we have the same progression from the left-hand side, right? And here are all the points that it's showing right there that we've put out here, right? So negative 0.1, 1.98, 1.99, 1.99999, and then we're getting dangerously close to 2. So this table, this methodology shows us that the limit as x approaches 0, not when x is equal to 0, right? But the limit as x approaches 0 of this function is 2. And just again, so you can see, if we actually put in 0, we get that undefined value. That doesn't help, but the limit gets us to the point where you can say, oh, fine, the value doesn't exist, but it's approaching that value of 2. So anyways, 2 is the final answer. That's how you do it. Done.